Hi, my name is Dan Funk. I work in the Office of Nuclear Energy in the Advanced Modeling and Simulation Office. And that's part of the Office of Science and Technology Innovation, NE4. And I'd like to talk to you today, just very briefly, about NEAMS. This is going to be a brief programmatic overview to give you a sense of what we're doing, why, and how we're doing it, and give you some technical details. I'm not the technical guy, but we will field your questions, and if we can't answer them right now, today, we'll answer them in the days to come. And of course, I'm not sure if Dave Pointer is online, but Dave is our technical point of contact, and our contact information will be in this presentation, along with some links to web pages that you might find helpful, and information, technical information at a relatively high simplistic level, yet we give you a chance to explore and drill down with our technical folks if necessary. So NEAMS as a program within NE is very, very excited about our investment in NEUP. We take it very seriously, and we have seen a lot of response in recent years, a growing response, and we feel that's a positive. So we look forward to hearing from you and saying, for those of you who have an area where you would seriously put forth a proposal, we're looking forward to seeing you and doing some good work together. So I think it goes without saying, at least with this crowd, why advanced modeling and simulation is important and how it can enhance R&D, and in some cases even what we might be so bold as to say supercharge it. But nevertheless, if it's going to be integrated into R&D, we've got to have a program that develops the capabilities to make that possible, and that is where NEAMS fits in. We always need to have in our, and it's a good thing to have in our programs, is a value proposition. What is it that we offer? Why is it important enough to fund us? Why even get involved with us? Well, we believe that we're in a good position, and we have already demonstrated some good faith efforts in this regard, and put out there some good products so far in the form of a toolkit, a box of tools that can be used together or singly. The effort is to take existing progress and go on, move forward from there in advanced modeling and simulation. See what we can do that's more predictive, that's more robust, easier to use. Whatever we can do to make it a better tool, and so they can leverage the advanced computing capabilities, as well as being able to be used on simpler platforms and a broader set of applications. What I'd like you to take from this slide is that what we're doing, we hope, will empower researchers and designers to transform nuclear technologies and gain fundamental insights that are unattainable through experiment alone. So in other words, we believe we can develop a set of tools that are easy to use and are worth using and have an impact not only in the near term but in the long term as well. So our objective is threefold. First, we want to help our R&D programs and their industry partners attain mission-critical goals. And some examples of that are listed here. We're working with the Accident-Tolerant Fuels program to help them reach some critical decisions. We're working with others to develop experiments for accident-tolerant fuels, and hopefully, if they restart as planned, the transient reactor test facility at INL, the treat, we would be able to design experiments for the accident-tolerant fuel there. Also with TREAT, we are developing the modeling and simulation tools that show promise in enhancing the operation and the research use of that facility. We're working on to have some high impact advances in innovative reactor design, such as SMRs. So there's real traction, and there's real efforts underway that command our attention and our investment. And we invite you to look into those with some of our folks and have a better understanding of what we're doing. Obviously, we have a very strong interest also in empowering new R&D in academia and helping to expand collaboration in industry and internationally as well. So when we got started, I guess to better understand where we are, it's good to see where we came from. When we first got started, our initial problems were focused on understanding the limitations of the conventional approaches to modeling and simulation, the state of the art at the time. And that drove us to some very basic questions. Why does a direction, well, they're listed here. I don't need to read them for you, but some of these of why does a directional bias appear in SFR fuel assembly temperature distribution measurements, or how accurately can we predict local neutron reaction rates? These are all important questions to deciding how we were going to proceed and whether or not it was worth proceeding. So as we gained confidence, that suggested that we focus on some problems to solve, and that generated some questions, and you can see here how that played out. And these were just some of our initial efforts in areas: spacer grids or wire-wrapped spacers, the impact of the missing pellet face on cladding performance, soil structure interaction, uncertainty impact. How does that impact seismic response predictors? And with the confidence in dealing with these questions, we took a step further and gave us some areas to focus on that gave us some truly new capabilities in our codes and our models, and also helped us focus on the initial validation that we would need to accomplish in order to deploy these tools even for initial minimal use. And as you can see here, as things crystallize, we really focused around two areas: the fuel performance modeling and reactor core modeling. And there'll be more on this in subsequent slides, but you can see how, as we progressed, we coalesced around these two primary areas, and we call these part of our product development lines, our core, part of our core program. And recently, as we started focusing more on deploying the tools and working on their validation, we developed another area of focus called high impact problems, which is defined here. The point I'd like you to get from this slide is that this is something that helps connect us to users and researchers, not only in labs, but in industry and academia. And the idea here is that each side would bring its own resources to the table and focus on a problem, and hopefully NEAMS would demonstrate the high impact of the solution, and the customer, whether it be a university or a business or industry, a vendor, or some lab participants and other R&D programs, would certify the high impact. This is an excellent way to ensure that our tools are robust and to help engender their reputation as being useful and reliable. So what you can see here in this slide is basically how we're organized to achieve these things. On the left there, you'll see the product lines. This dotted line shows the product lines: fuels, reactors, and integration. And below that, you'll see the high impact problems. We have two currently underway, and these are 3-year problems that programs or projects, I guess you'd call them, where we are working on to achieve a high impact on two critical areas. And then we also have another area called mission support. That's where we're using our modeling and simulation development efforts to support the operation and use of TREAT. And then over on the right-hand side, you'll see the investments. These are areas that are more outward-reaching, investing in helping our develop a framework for our tools to operate more efficiently or more effectively, university research, small business innovative research, areas that would help with our user groups and collaborations, and with developing and expanding uncertainty quantification and quality assurance, which are important to the use of any new capability. All right, so what you see here, we've got a national technical director right now. Currently, it's Maria Stan. Chris Stanek from Los Alamos is going to start as the NTD in September, and you can also see how the tools line up. In the fuels area, for instance, it's focused primarily on Bison and Marmot. Reactors area, it's on Sharp, and you see Relapse 7 mentioned there. That's really a code that's being developed in the light water reactor sustainability program. So it's not the focus of our scope for this NEAP call, nor is it the main focus of our efforts right now in that area where we're developing other systems analysis models. And then integration. Whereas the fuels and the reactors might be seen as our flagship capabilities for NEAMS, those ships would never even get underway, let alone navigate to where they need to be without integration. And you can see Dave Pointer leads that area. So not only does he work on the frameworks and the meshing, the visualization that helps these tools work singly or coupled, he also is the main point of contact for our outward external efforts, our outreach, and specifically our NEAP efforts and investments. So taking a step back from that, this organizational look at how the things are lined up, then we can look at this in terms of our business model approach. And this is internal. This doesn't reflect so much the outward efforts that we have to work with industry or universities, but it gives you an idea of how you have the opportunity to work with us as well. So you have the NEAMS pellet to plant simulation toolkit. That's being primarily produced by our product lines, the fuels product line, reactors product line, integration. They develop, validate, and deliver these capabilities into the toolkit, and through that to our R&D programs in NE primarily. And there, those tools are put to use and integrated into the programs, and if they might even be at that point, they might even be something useful to industry. Then we have the area of the high impact problems. That's coordinated through the product line leads, but managed directly under technical leads for each high impact problem. This is primarily an area where we take and deploy the capabilities being produced in NEAMS to solve a problem, and in that sense, that since it's a well-defined problem, it lends itself to supporting and expanding the validation base case for whatever tools they're using. And the users there, as I mentioned before, could be in any number of areas, whether it's industry, the labs, or academia. They solve the problems. It can even involve some benchmark and validation work, and similarly, in the mission support with modeling and simulation support for TREAT, which is also managed and coordinated by the NEAMS product leads. And they, again, deliver tools that are implemented for ongoing use. Now, from both of these groups, the use and the deployment of these tools can lead to improvements, which then are fed back into the core program, and also help support the validation case for each of these NEAMS tools. And that pretty much completes that picture there. That's just an internal business model. Now you can see it doesn't involve our direct connection with the industry. It doesn't involve the direct connection through NEAP with the universities, but your interaction with us would fall along similar lines. So let's take a look at the two flagships, the fuels and the reactor side. Fuels focuses on the pellet to pin fuel simulation. Here, the holy grail, if you will, is the microstructure changes in the fuel. To understand those is not an easy lift. So we take the empirical models we have are very useful, but our goal is to improve upon these with mechanistic materials models for fuel performance that can help us predict fuel performance and failure probability. The approach starts with atomistic simulations and using those as inputs to mesoscale model development, which then gets inputted into an engineering scale model that will help us provide a better tool for not only researchers but analysts and designers. The way this looks in the fuels product line with the tools is that we have the lower length scale where we have the atomistic and the mesoscale material model development, Maramet, and that operates on Moose along with Bison. Bison is the engineering scale fuel performance tool. The takeaway here is the link at the bottom of the screen of the slide of the Bison page that you can go to and get a lot of useful information, and we can provide a lot more detailed information as you might need it to develop a proposal. On the reactor side, that focuses on the core to the full plant spectrum there of the toolkit. Here, the central driver is multi-scale and multi-physics simulations in the core dynamics, the core mechanics, core thermal hydraulics, covering timescales from picoscale picoseconds to seconds to days, and able to achieve coupling and interoperability as needed. The heart of this is the Sharp Sigma module. Sigma is the framework, and the three Sharp codes are Proteus, NEC 5000, and Diablo. Also here, there are a couple of links that can help answer your questions, or at least maybe even help you go see what you might want to ask if you're interested in it. I won't go into a lot of the details here, but I want to provide this slide for you so you can also follow the link here and look into some of these details if you're interested. NEC 5000, the thermal hydraulics module, has been undergoing a lot of development, and in fact, the recent work is helping it to be applied to LWRs and two-phase flow. Proteus is also undergoing a lot of changes, and there's a lot of work underway to couple Proteus with other modules and with other models. So here again, there's some information on Proteus and some discussion of the development work that's already underway. Diablo, the Sharp's structural mechanics module, is also being developed and we're interested, as you'll see, in how it might be coupled with other models when we get into the scope. So we've taken a different approach this year with our scope. We've always had just one scope, and we've always received a lot of interesting proposals, but some of which address very different areas of NEAMS. And so it's been very difficult to compare apples to apples when we only have one scope, since we get a lot of different proposals, all worthy of our serious consideration, and yet some very difficult to focus on because it's just one scope, and it's difficult to compare them appropriately. So what we've done this year is we have 4 areas in our scope. You can see them listed here on the slide, and they address different approaches, different aspects of NEAMS. As you can see, they're atomistic and mesoscale modeling of fuels and cladding and reactor structural materials, then macro scale fuel performance modeling, and then core neutronics, and then thermal hydraulics and structural mechanics. There'll be a little bit more on that in just a minute. The proposals should clearly define quantitative metrics of success. That's important. We want to know from you how you are quantifying success, so we can evaluate that. Proposed model development and validation isn't restricted to one scale or one type of experiment, either single effects or multiple effects. We really are looking to see if you have something that's single scale or single effects, that's fine. If it's something that's more integrated and comprehensive, that's fine as well. We're interested in the full range. Simulations or conducting experiments are important. If they're done at DOE facilities or at the nuclear science user facilities, that's encouraged. But you feel free to use computational experimentation facilities at your own labs if that's better for getting the work done for you. Of course, we encourage collaboration with members of the NEAMS development team. And please, it's on the slide here, but I'm going to emphasize it, focus on just one of the 4 areas. If you believe it's in more than one area, we'll just have to make a decision and put it in one area, because that's how that's going to be how we evaluate it and compare it with the other proposals. So if you please put it in one of the areas. If you don't, we'll have to do that, unfortunately. I prefer that you do it. And here are the points of contact: me, my email address and phone number, and then Dave Pointers, who's at Oak Ridge National Lab. Now, the specific areas, I'm not going to go over all the details here, but the next 2 slides are there for you to see. You can read it in the call itself, but here is a useful summary that you can use as a handy reference. In the atomistic and mesoscale area for fuels, cladding, and reactor structural materials, one of the things I wanted to emphasize on that was that proposals on atomistic to mesoscale and physics coupling using Marmot are also encouraged. We'd be very interested to see what you have to propose in that area. Macro scale fuel performance. Again, you can go down the list of bullets of what's desired. Again, coupling of Bison and Marmot simulations, whether it's sequential, concurrent, or hybrid, are encouraged. Core neutronics. In this area, in addition to the things that are listed, proposals that consider the integration of the NEAMS macroscale fuels and neutronics capabilities are also encouraged. Those are some of the, what I'm mentioning are the areas the items in each area that are particularly challenging and would be of particular interest to us, in addition to the things that are listed above. And then the thermal hydraulics and structural mechanics. As I mentioned, there's a lot of work going on in those areas. You can see here what we would be interested in, and then I add to that anything that also might integrate NEAMS tools for thermal structural or fluid structural applications are encouraged. So with that being said, if that's the close of my overview. So if there's any questions, I'll be glad to either try to answer them or direct them to somebody who can.
So we'll take questions over the next few minutes. As a point of clarification, as Dan said, there are sub areas, and similar to other NEUP work scope areas, this means that you will be able to apply to one of those sub areas, 1.1, 1.2, 1.3. Oh, sorry, NEAMS. Sorry, I said NEAT. So 1.1, 1.2, 1.3, and 1.4, meaning you will not be able to submit to the NEAMS work scope itself. You'll have to submit to one of those sub work scopes. Are there 5? That's one of the questions, actually. There are 5 work scopes in the draft, 1.4 and 1.5. We're separated out. Are those in the final draft going to be 1 work scope or 2?
What do you mean?
Are they going to be 1 area or 2 areas?
Oh, he split. Okay, so
okay. They have been split out.
All right. Okay. Yes, I can see that now, and I apologize for that. It got by me. So yes, that's going to be there's going to be 5. So it's going to split out the. That actually will make it easier on submitting the proposals. So my apologies. Say that. Would you repeat that question?
Are proposals focused on developing new nuclear fuels or materials using the NEAMS toolkit codes sought?
If for instance there were a proposal that would explore expanding the application of a NEAMS tool to a fuel form that we're currently not focusing on as much, that would be welcome. Yes. And in particular, I guess I'm looking at things, considering this in terms of we're always interested in expanding the application of the NEAMS tools. So if there's nuclear fuels that we're currently not actively or is not as receiving as high priority funding, then we certainly would welcome a proposal in that area.
Right. As an addition, Dan, I might add that there would be an expectation that a proposal would include either use of or generation of appropriate validation data for that application.
Next question, are the NEAMS toolkits the only acceptable computational platforms for proposed new model or algorithm development?
I'll let Dave field that one.
So I think, I'm sorry, there's a weird echo for me, and it sort of slows me down. I apologize for the stutter. In the past, we've accepted proposals for work that have done development in other platforms, as long as the proposal also includes effort to demonstrate the translation of that new capability into the NEAMS toolkit. And I think that that's a reasonable approach for us in general in the development of NEAMS tools. That's not just restricted to NEUP. We do occasionally develop models and methods in other platforms where there's an ease of use issue that allows us to do that more quickly, more cost effectively, but there's always the expectation and requirement that the capability be moved back into the NEAMS toolkit.
Thank you, Dave.
For NEAMS 1.1, is it necessary to use Marmot?
Well, I'm trying to figure out a way to say that it's not. Dave, I would invite your comment on this. I don't want to close the door to innovative approaches that might be then ultimately be implemented into Marmot. I certainly can envision atomistic work that might not initially include Marmot, but then ultimately would be used. But that Marmot is our primary tool for ultimately implementing more advanced mechanistic physics models into Bison. So we're pretty much committed to that. But I'm not sure if I'm missing the question. Dave, what do you think?
Dan, I think you covered it pretty well. I think there are a lot of opportunities for work at length scales that fall below those resolved by Marmot itself. But as in the previous question, there would be an expectation that the models developed or the understanding developed is going to be coordinated with the Marmot team to be implemented within the framework of Marmot at the close of this project.
For neutronics coupling with fuel performance, do you require PIs to consider using Proteus only or using Rattlesnake, or would using Rattlesnake be acceptable?
I think that we would welcome either. We're developing primarily Proteus. I think that Rattlesnake is a tool that is starting to have some use for NEAMS, and but the primary tool in our toolkit is Proteus. So we would look at it from that perspective, but certainly be open-minded to seeing what people could do with Rattlesnake. But here again, the point is that would the proposal result in a capability that would then contribute to broader use of the NEAMS toolkit, enhancement of the NEAMS toolkit, better validation of the NEAMS toolkit, or at least provide data that would support future advancements of the NEAMS toolkit. I think that little laundry list there I just put out is really the answer to the question. Dave, did you have something to add?
I just might add, it may be worth noting that there are two major NEAMS deliverables for the end of FY15 coming up in September that are focused on providing a couple of Moose apps which simplify the integration of Proteus with the Moose-based components.
Yeah, that's a major effort that's been underway in NEAMS. So that would be our focus.
In NEAMS 1.1, is modeling of irradiation effects on long-term behavior of concrete elements being considered?
Well, quite frankly, I have not thought of that. Dave, did you have some thoughts on that?
So it's part of our long-term plan for NEAMS, but it's not something that's being considered in the current NEAMS program, and likely would not be for the within the term of this NEUP. The initial focus for NEAMS has been in core, with some slight extensions beyond the core for thermohydraulic effects, but we have not started looking at effects beyond the core barrel in any reactor concept at this point.
Is there interest in development of adjoint methods for uncertainty quantification and coupled criticality and burnup codes in NEAMS 1.3?
I'll let Dave answer that as well.
The short answer is yes. There's always an interest in uncertainty. I would advise anyone developing a proposal in that area to try to get in contact with the folks working in that area in NEAMS already, to make sure that their efforts are consistent and complementary to the work that's in progress.
What is the difference between NEAMS 1.1 and NEAMS 1.4 for structural materials?
I believe the focus for 1.1 would be atomistic and mesoscale modeling and simulation, and in that case, primarily our efforts have been in fuels and cladding, and we were trying to open that up to exploring some of that lower length scale work in reactor structural materials. Whereas 1.4, or I guess it might be 1.5 now, is going to be primarily focused on the core analysis. So Dave, did you have an idea on that as well? I can see why there's that optics problem with these.
Sure. So in 1.1, the connectivity is really to the the macro scale fuel performance modeling described in 1.2. In 1.4, the focus is on is much more heavily placed on large structural components of the core, such as core support plates, core barrels, and those types of features. That may appear in various reactor designs. That are not typically associated directly with the fuel, but have an impact on reactor core performance.
Would detailed measurements within facilities that do not necessarily use water be acceptable for the thermal hydraulics area 1.4?
I would say the simple answer to that is yes, depending on where the proposal was going to take us. Dave, I don't want to say no to things like I think we need that's precisely what we want to explore, or a broader range of reactor types, and that could include a lot more than just what we have currently underway.
So the focus for NEAMS has always been to develop a set of tools that are not necessarily tied directly to a specific reactor type.
Right.
One of the challenges for the development of these components has been to provide tools that are flexible enough in their implementation to adapt to a wide variety of materials and design concepts. So I think that universally applies throughout the entire NEAMS call.
Yeah, the only reason I had a caution in my reply was that it would be linked with advanced concepts that are currently being explored by our major programs, unless there were some compelling reason to consider something completely different. But yes, if the tools are to be more broadly applied, certainly different materials, different coolants would be in play.
For 1.1, is the envisioned balance in favor of coding and developing models rather than fundamental science such as microstructure evolution?
To me, it seems that understanding the microstructure is definitely in play. I'm not sure that we had some kind of balance in mind. I think how we would view a proposal would depend on the impact the work might have on NEAMS, and whether it's in the understanding of the physics and the microstructural changes, which would lead to better models, or in the other area. So the question is, can the work that's being done actually be connected? Is it connectable to our efforts and to our program, meeting our program needs? Is that all right, Dave? I mean, from your vantage?
I agree with you completely, Dan.
Okay. If that didn't answer the question, we can talk about it more offline.
Are improved SN methods considered?
I'm not always in agreement with those who are technical experts and the guys who really know what they're doing. So I will defer to Dave on this one. I'm open to. I always like innovative approaches, but sometimes I'm not aware of what is already been known to be a fruitless path. So I don't want to lead anyone astray. Dave?
Unfortunately, I'm getting some interference. You're breaking up, Dan, so I'm not quite sure what your response was.
It's okay. It's not
that
going to be worth as much as your response anyway.
So assuming you can hear me better than I can hear you, I think that the work in method development is for any method is reasonable, as long as it meets the expectation that the work that's being proposed is going to provide some assurance that this is some assurance that this is representing the reality of the phenomena being modeled, and also as long as the criterion that the work or the proposal clearly define the metric of success that illustrates a return on investment for that development effort. So I think yes, SN methods are certainly acceptable, but we would want to see a very clear statement of an anticipated metric of success that would justify the investment in an additional SN method, which has been a substantial focus of the program anyway.
Is modeling the effect of irradiation on stress corrosion cracking of core steels considered?
Again, I think if you propose work in that area and you demonstrate how it will help in the fuel performance modeling and more importantly failure prediction, then I mean, it would be worth seeing. But maybe I'm misunderstanding the question. Dave, did you have an insight on that?
I think my response would be very similar, Dan. I think the key for us would be to see again a very clear metric for success that illustrates the return on investment for the expansion of capability of the NEAMS tools and our ability to address problems of importance to DOE and E.
Yeah, and we're not presuming that that area would you mentioned in that question would not be fruitful. Just caveating our answer with saying that that's something that would have to be, the fruitfulness would have to be something that could be demonstrated, at least the potential for it.
Under NEAMS in general, are experimental collaborations coupled with simulations fundable?
The short answer is yes, but it depends on the scope. The coupling of we're not talking about codes or simulation tools, computational tools here. We're having a coupling of experiment and modeling and simulation. I think is essential. I'm not sure that R&D can be fruitful and competitive without it. And maybe I'm misunderstanding the question. But if it's something that exceeds the allowable price tag, unfortunately, it would have to be we'd have to break it down and take it one chunk at a time, or maybe consider it if there's something that is so powerful and promising. We would be willing to maybe consider alternative ways to approach it, if not in the current year or in future years. So that's a philosophical answer to your question. I hope it's satisfactory. If not, please pursue it with me or Dave.
Is it expected that there will be several proposals funded in the NEAMS area as a whole, potentially one for each work scope area?
We believe that we'll be in a position to achieve at least one in each work scope area. We're not committing to that, however. We can't promise that. That wouldn't be prudent or wise, because we just haven't seen what we might get, and also in terms of proposals, and also what funding might be available. We just don't know. And I wish I could answer that, and I wish I could guarantee it, but we simply can't. But that's you know, since we have those areas, we take them all seriously. So we're interested in investing in all those areas.